Hello, I go by the name Bridget Amaki Otu of Data Science and Analytics. I'll be explaining cache memory and its techniques. Introduction to cache memory. Web browsing. Cache memory enhances web browsing speed by storing frequently accessed web pages and resources, reducing the need to fetch data repeatedly from remote servers. Gaming performance. In video games, cache memory improves performance by storing game assets and frequently used data, leading to quicker load times and smoother gameplay experiences. Database management. Cache memory plays a crucial role in database management systems by caching query results and frequently accessed records, thereby speeding up data retrieval operations. Types of cache memory. 1. Direct mapping. Direct mapping is a simple and effective caching strategy used in many modern CPUs for quick data access. 2. Set associative. Set associative mapping allows a block to be stored in any of a limited set of cache lines, improving hit rates. Fully associative. Fully associative mapping enables any block of data to be stored in any cache location, maximizing flexibility. 4. Cache replacement. Cache replacement policies dictate which data to evict based on usage patterns, optimizing the cache efficiency. Types of cache memory. L1, L2, L3. L1 is the fastest cache located on the CPU chip. L2 slower than L1 but larger in size. L3 shared between multiple cores in CPU. For the comparison, each level balances speed and storage. Techniques for cache replacement methods. 1. LRU, which is least recently used. This is a common strategy that evicts the least recently accessed cache entries. 2. FIFO, first in, first out. This method removes the oldest entries from the cache, regardless of usage frequency. 3. LFU, least frequently used policy prioritizes keeping cache entries that are accessed most frequently. 4. Random. Random replacement evicts a random cache entry, which can be efficient in certain scenarios. Importance of cache memory in computing. 1. Faster data access. Cache reduces latency by storing frequently accessed data locally. 2. Improved performance. It reduces number of slower memory accesses, increasing overall system speed. 3. Energy efficiency. Lower power consumption by accessing data from cache instead of main memory. Scalable architectures supports multi-core processors by minimizing contention between cores. Cache replacement policies explained. These are we have the pros and the cons. The pros: 1. Increased efficiency. Cache replacement policies enhance the efficiency of memory usage and access speed. 2. Reduce latency. Proper replacement policies minimize latency by making frequently accessed data available quickly. 3. Improved performance. Adopting suitable cache policies directly boosts overall system performance and responsiveness. Moving on to the cons. 1. Complex implementation. Some replacement policies can be complex to implement and maintain over time. 2. Increased overhead. Advanced strategies might introduce overhead which can counteract their benefits in speed. 3. Risk of thrashing. Inappropriate policies can lead to thrashing, degrading system performance significantly. Cache coherence in multiprocessor systems. This cycle is where how the cache cohere in multiprocessor systems. 1. Detect. Identifies when a cache line is modified. 2. Notify. It informs other caches of the modification. 3. Invalidate. Marks stale cache lines in other processes. 4. Update. Update the value in the invalidated cache. Moving on. 5. Access. Allow access to updated cache data. 6. Respond. Send acknowledgement of updated cache status. 7. Repeat. Continue the coherence process as needed. 8. Maintain. Ensure all caches reflect the latest data. This cycle repeats itself over and over. Cache memory architecture and design. In terms of size, speed, and its impact, L1 cache is 32 kilobytes in size, speedy and lowest latency. L2 is 256 kilobytes, faster and medium latency. L3 cache is 2 megabytes in size, fast and higher latency. The cache miss, not applicable in size, slow in speed and performance drop. Highlights. 1. Efficiency. Cache memory boosts performance by 90% overall. 2. Cost. Higher capacity cache increases CPU designer cost effective. 3. Speed. L1 cache provides fastest access times for CPU operations. Emerging trends in cache memory techniques. Summary points. 1. Increased capacity. New techniques allow larger cache sizes, boosting performance. 2. Lower latency. Advanced algorithms reduce access time significantly. 3. Power efficiency. Emerging strategies minimizes energy consumption in caching. In the slides, we've realized, or maybe you haven't, but the word latency has been mentioned a lot of times. Latency refers to the delay between a request for data and the start of the response. In computing and networking, latency is the time it takes for a data packet to travel from source to the destination. It is usually measured in milliseconds. Thank you for being with me. Hope you understood whatever I presented on. Thank you.